Everybody, I want to present SDN and NFV. Now let's start. I'm Amir Senatai, and this slide about course mobile radio network. First of all, let's start with SDN. It's all about networking, control function for routing and policy definition, and this entire thing is done in very automated way. And with SDN, what we are going to do, we are going to ensure the IP and network reachability is going to happen well in time. Both SDN and NFV architecture are going to use network abstraction, but they do it totally in different way. SDN provide a new level of programmability and abstraction to network layer, which is play a phenomenal role in automating the network. Let's take a deep dive on SDN and let's understand how it works. Our topic is about SDN. It stands for software defined networking, highly correlated with NFV. SDN is the big thing in IT and telecom industry, while NFV is all about building virtual platform. SDN is making IP network much more programmable, so that packet routing is possible with lots of flexibility and agility. As shown here, SDN is based on concept of separating a brain and control plane for traffic routing. This is the separation of brain and control plane and make SDN a very powerful tool for customizing network on the fly. With SDN you can provision new bandwidth and define traffic failover just like never before. Just see the building block which represent the NFV and host multiple application. Just like you can remove, replace, or keep new tenant in building, similarly you can host application in NFV as well. You can see traffic on road representing SDN, whose main responsibility is to carry traffic to right destination in very automated way. First thing, let's understand why we need SDN and how it is helping. We have seen the NFV help the virtualizing network, which help us in a rapid deployment and ultimately reduce our deployment time of new service or new nodes. Now NFV does it in few seconds, but what about network reachability? The network connectivity and reachability is a real problem for any new node or new service. We need multiple things such as the IP allocation, the bandwidth allocation, the policy opening, and the routing change. Actually, we need to do end-to-end reachability, and for doing that it takes a lot of time. It takes a lot of time to prepare design, to execute the change, and we need to do in every router, every switch, and so on. This is also prone to mistake. For doing the network reachability piece, we take few days or also a few weeks. Ultimately, even if the NFV resources are available, but we can't launch the new service or we can't make the new node live because our network reachability is not done. The SDN is going to help us specifically out here, and you can see recap the benefit of future of SDN based below this slide. And the next slide, let's understand how SDN work. This is our traditional network where traffic is moving between various switches and router. In order to reach the final destination, SDN change how networking is fundamentally done. Instead of having a network intelligence which is distributed in every device, I mean to say every router and switch applying its own brain, SDN aim to centralize the brain. SDN aim to centralize command and control into centralized node, and it's going to distribute the entire things in different control plane and in a different data forwarding play. And now let's understand how these different play work out there. The second one is a data plane. We also call it as forwarding function or forwarding plane. In traditional networking, traditional router and switches, there are multiple nodes which are connected to each other. All these multiple router and switches, they are connected to each other with a line card, and the link running between this line card, this is where the data is actually moved from the one device to another. Visible on screen traffic is going all the way from router, that is how to packet are following here. We call it as a data forwarding plane. And the next one is control plane. Well, in traditional network, the role of control plane is to take routing decision. Every router is having its own brain. You can see brain in this orange color, which is like rotating out there. Every router applies its own brain to decide the best path to route the traffic. That's the power of SDN. We're going to bring this resiliency into the network. And the last one is the management plane. Now in traditional network, this is used for performing operation and maintenance of network. I mean to say, you can do the configuration, you can get the report, you're actually running the network out there. For example, we use a management plane for fetch report, perform configuration, get alert and alarm. You can see who is logging into every router and doing the configuration, and there's a screen if you have an open new route. And now let's see how SDN simplified and the life, and what good things SDN is going to bring to this particular network. The SDN is a powered network wherein the controller or brain of network is separated from data or forwarding play. SDN will change dramatically the way we're designing the network, the way we're managing the network, and the way we're running our network. Before they discuss this further, let's understanding this is emerging architecture of network that is fully programmable, a much more dynamic network. It's manageable, and it is cost effective. It is also adaptable. And now let's understand the SDN framework. The SDN architecture OpenFlow protocol is key to entire topology. As you can see, the blue color out there, this is OpenFlow integration. The OpenFlow protocol is key to the entire SDN topology, and you can see we have two northbound and southbound. Northbound for API and the application programming interface for the business application, and also in the below of this slide we have the southbound for controller, for example OpenFlow, to control the network devices. Let's go to NFV. The telecom industry is going through a revolution where cloud native network are going to become a necessity. If you want to be technically competent, grow and rise in telecom, you should learn and upgrade yourself about the cloud technologies such as NFV, such as SDN, also such as container and hypervisor. The next slide, while NFV covered the softwareization, the virtualization, and makes the building block ready, the SDN does the totally different things. The SDN forward the data packet from the one network device to the another one. At the same time, SDN network controller function for routing and policy definition are building the highway and the pipeline where our traffic can reach to its destination. NFV is all about three main components, which is we're going to cover and discuss in detail. And the first concept is softwareization, the second is virtualization, and the last one is orchestration or automation. Okay, this is a classic network of 4G which is deployed across all the mobile operator across the globe. We will see how this typical 4G network, which is a typical traditional network, the way it have been deployed, how are we going to virtualize this. You can see that all these nodes they are deployed on traditional hardware. We also call this purpose-built hardware. This is specialized appliance or hardware which is meant to perform a very specific function. For example, we can see this individual hardware rack serving the individual functions such as the router, the PGWs, the HLR, the MMME, the OSC, the PCRF, the DNS, and so on and so forth. A typical set of and the type of hardware. The problem with this type of deployment is the lack of scalability. There is also problem with lack of speed and the lack of flexibility. Also business, as there is always a delay in the new product launch, and there is always an issue for the meeting the customer requirement. Now let us understanding what is NFV and how NFV solve this issue. NFV stands for Network Function Virtualization, and as we have discussed, they are going to do three things. The first one is softwareization, second is virtualization, also last one is orchestration. And if you replace the costly, dedicated, and purpose-built hardware with a generic server that use software to provide a bunch of different virtualized network function, we call it at VNF as well. Virtualization is all about software package that perform a specific function. Such as it can work a router or virtual router, it can work as a switch or virtual switch, it can work as a virtual HLR, it can work as a virtual MSC, it can work as a virtual SMSC, and so on and so forth. You only need to increase the license and the compute the storage in this order to increase or decrease the capacity, and then you can take a capacity and increase. You can do the scale up and also do the scale down. It's flexible. And if we use the virtual machine as the key building block where application can be hosted, these virtual machine are having flexible capacity and can host any application. NFV turned the traditional network hardware into the virtual network function, and this virtual network function, they are running a generic hardware. We also call generic hardware as COTS. COTS stand for commercial off-the-shelf hardware. NFV also enable the service chaining, which helps multiple function to be used in technology. We'll understand all this concept moving ahead in the NFV architecture. Now on the left side you can see the framework of the NFV, which have been delivered, deployed, and standardized by the HC team. And now what is the need of the framework in particular group which have been formed by HC. This group have came up with the architecture, a framework, and a specification for NFV. There are three main components of the entire architecture. The first one is the NFVI, and the second one is the VNF, and the third one is the mono. This architecture ensures the tight coupling between the hardware and the software. Now let's move ahead, and we are going to get into the deep end. We are going to understand how the cloud infrastructure work out there. So we are going to cover the concept of VNF in more detail in the slide. VNF is hosting three telecom node as a virtual application. Can allocate resource to three virtual node and the basic of requirements such as virtual HLR, virtual MSC require much more compute. All of this individual virtual network node can have a reserve compute, reserve storage, and reserve network. Now let's understand the NFV architecture in detail. We'll start with the bottom layer, which consists of NFVI and VIM. You can see on the bottom, NFVI stands for the Network Function Virtualization Infrastructure. The role of this layer is host the hardware and manage the physical part. And jump to the second layer. Now this is the layer we're going to discuss the VNF and VNF manager. This is going to be critical key component for the virtualization. A VNF is network function using the software that is decoupled from the underlying hardware. This virtualized network function run inside the virtual machine. We call it VIMs. We have you can see it in the industry. We can have virtual SMSC running on two virtual machine. Now you can see three layer of the FCAP or operation and maintenance which are out there, which have been discussed to first layer in FCAP or operation of NFVI and virtual machine or hardware. This is done by the VIM. We also call it virtual infrastructure manager. And second was the FCAP or operation, the VNF manager. I mean to say the creation of VNF, deletion and of VNF, the performance of VNF and all of that is run by the VNF manager. Now let's cover the last building block of architecture block for the NFV, which is orchestrator. This orchestration is the node which you can see in the yellow color. This is the key of any type of automation except of the SDN and the NFV. This is a part of NFV framework, and it is also now the name of NFV Mono. It's basically a component of the NFV Mono. This is also called as the NFVO or NFV orchestrator. And you can see at this slide as a reference at the last slide